Hi, we are going to do 3-1 notes today, lines and angles. It is the 15th set of notes and it's on page 40 in your note guide. So we have a warm-up today and it is midpoint, which we've done a few times. We've done a lot of midpoints. Average of the x's, average of the y's, add the x's together, add the y's together, divide by 2. This one we throw in a little trick. There's some fractions. Don't freak out. You can handle fractions. Again, those of you who are really comfortable with it, go ahead and pause, work it out on your own. Otherwise, come here. We are going to solve it with a complex fraction technique, which is probably new to most of us. A lot of us will know how to do it with some skills we've had before. We're going to throw in a new skill that will be something you'll be able to use with Algebra 2 later on. So we want you to kind of get this skill down. Okay, so again, average of the x's, average of the y's. I'm going to add 5, 6. I'm going to leave space because I'm going to show a lot of work in here. Plus 8, divide by 2. I'm going to put like a little comma here. And then on this side over here, it's going to be negative 7/9. Plus, and again, I'm leaving a little bit of space because I'm going to show some work in here, 2/3. Now, this is going to be an ordered pair when you do midpoint, adding x's, adding y's, divide by 2. Okay, what needs to happen is I need these two to be a fraction. So I'm going to use another color, probably pink. I need to add these two numbers together, and I can't add it right here. I need to make this a fraction, so I'm going to make the 8 over 1. They need to have a common denominator for me to add these together. So what I need to do is I need to multiply by 6. What I'm going to do is I'm going to multiply this side over here by 6 over 6. And when I do that, I have to do it on the bottom as well. On this side over here, my common denominator has to be the 9. So I'm going to multiply by 9 over 9 here. And this is going to help me clear the fraction and add those together. So I'm not going to get a common denominator. I'm going to get rid of my denominators, and then I'll just add the tops together. So I'm going to distribute the 6 through. That'll be a 6 here and a 6 here. Don't forget to distribute the 6 on the bottom. That's one of the things that are easy to forget. Over on this side, I'm going to distribute a 9 and distribute the 9 on the bottom. Okay, so that's how I do it, and I write it in. That's why I leave the space so I can write those in. So this 6 is going to cancel. That'll stay the same. So this over here is going to become 5. 8 times 6 is 48, all over 12. This side over here, the 9s will cancel, leaving me the negative 7. 3 goes into 9 3 times. 3 times 2 gives me a 6, all over 18. Okay, so now you can just simplify these. You're still going to have a fraction as your midpoint, which is fine. You start with fractions. 5 plus 48, we end up with 53 over 12. And here, negative 7 plus 6, we end up with negative 6. Oh, that's not 6. Okay, negative 6. No, sorry, negative 1. Negative 1 over 18. Now you always, always, always check to see if you can simplify one last time and there are no common factors, but always check to simplify in case you miss one thing in there. Okay, but that's it. I want you to you're doing midpoint, but now it's with fractions and it's a new technique. So go ahead, you can cover that up, practice it again, or print out another paper, or covering it up and practicing it again in scratch paper is probably a great idea. Okay, we're going to do some definitions for 3-1 now. Parallel lines are shown by 2 long L's. They're a little bit longer than a regular L. That's the symbol we use when we're writing it. They are coplanar. They do not intersect. And we draw these thick arrows on the lines to indicate that they are parallel. So if you ever see those thick arrows, that means that they're going to be parallel lines. Parallel planes are going to be planes that do not intersect, so like walls, the ceiling and the floor, something like that. Skew lines are lines that are not coplanar and they do not intersect. so they're not parallel, because parallel lines would be on the same plane. But skew lines are going to be lines that don't intersect and they're on a separate plane. If I show you this box, you guys can see me in the corner. Skew lines would be something like this and this. You can see those two lines. They're never going to be on the same plane. They're not going to intersect. They're skew lines. Okay, so next we're going to look at this box. Take a minute, answer these questions down here. Pause it if you can. I am going to highlight in blue TWs talked about in each of these. Not the last one. I'm going to highlight TW here so I can look at that. And then I also want to pay attention to V. In every one of these it's asking me about V. Well, V is located right here. So that's where my focal point is on this picture. I want to know parallel to TW and through V. Oh, excuse me. UV is going to be my answer, that one back there on the bottom. So I'm going to write UV, and it's a line with the arrows on the ends. Perpendicular to TW and contains V. So again, work ahead of me. I want this alphabetical, so it's going to be VW. Skew. Now there are a few that I can name that are skew. Skew is going to be RV is probably the easiest one to visibly see. So RV is probably the best one. But there are actually a lot that are skew. QV works. SV works. PV works. So those are all different skew lines that are not parallel and not coplanar, not parallel. Do not intersect. Okay, the last one here, planes that contain V and are parallel to plane TPQ. But first, I need to know where plane TPQ is. So TPQ is over here. It's this plane right here. I'm going to shade it in. So in that box, that cube, the plane that's parallel is going to be this plane over here that's already shaded. So I'm going to write plane. Anytime I name a plane, I name it with 3 points. I want it to be alphabetical on that plane. So it may not be in order. It's going to be at RSV, which is hard. Like you want to say RSW or SRV. But if I'm naming it alphabetically, their RS and V comes first. And even it doesn't matter. They don't have to go in order on a plane. So RSV is going to work. Okay, now parallel postulate here. Parallel postulate, if there is a point not on a line, then there's exactly one line through the point parallel to the given line. If there is a point not on a line, then there is exactly one line through the point parallel to the given line. So I'm going to start with this line over here. Let's say that there's a point out here not on that line. There is exactly one point, one line through that point that's going to be parallel. So I'm going to draw that right here. I'm going to make it pink. There will be exactly one line that would be parallel going through that point. To indicate parallel, I put those thick arrows on the line, and that's how that's going to work. Now, perpendicular, and I'm going to do it on the same one. If there is a point not on the line, then there is exactly one through that point that is going to be perpendicular. So I could draw it like this. Through the original blue line, there will be exactly one line that is perpendicular. Now, the symbol that I'm going to use for perpendicular is that right angle. Every time you have a right angle, it's going to be perpendicular. Okay, I'm going to pause. We're going to go to the next page. Okay, so on the next page we have another construction. I know a lot of people were uncomfortable and didn't want to do, and that's fine. If you don't have a compass or a protractor, that's fine. You don't have to do the constructions. I'm just going to go through it for those of you who want to see it. It's on page 130 in your textbook. So you can see it or look at it, see how you would do it. It's not required. We're not asking you to do constructions right now while you're at your house. So I'm just going to show you. All right, so if I want to construct a line that is through P, P's down here, and perpendicular to L, what I'm going to do is from P, I'm going to put my point on P, and I'm going to make a little half circle mark and intersect the line in 2 spots. So this distance from here to here is the same as this distance from here to here. I'm going to go ahead and make those points right now. Now, after I make that first half circle, now I'm going to go to those points using the same distance. So I didn't make this any larger or any smaller. I'm going to go here to this point, and I'm going to make a little arc up top. I'm going to go to this point. I'm going to make this arc over here. Now that I've done that, that's pretty much it. I've got to go from this intersection that I just created and create a straight line through P. So I just created a line. We'll call this line M because this line over here is L, and this line is perpendicular to, M is perpendicular to L. Another thing that's neat is that this length from here to here is the same distance as this length from here to here. Those will be the equal distance as well. So I can say L is perpendicular to M. There we go. Okay, transversals. I like transversals. And one thing about them is they do not go away. You need to know them. You need to know the relationship for the rest of the year. I'm going to ask you these all year long. Okay, transversal is a line that intersects 2 or more coplanar lines at different points. So I'm going to call these 2 lines like M and N. My transversal is one that intersects both of them. So I'm going to call it T for transversal. Okay. I always think, how are they related to each other? I think of like north, south, east, west. And draw a little north, south, east, west. Corresponding is in the same corresponding position. So if I want corresponding to angle 1, angle 1 is down here. Now I don't care about vertical and linear. Okay, down here, sorry. I don't care about vertical and linear. These 4, I already know the relationship. So I want a relationship from one of these angles to one of these angles up here. All right, you don't, inside the same 4, I already know if they're linear pair or vertical. I know that. So I want one is down here, and it's in the southwest. So I'm going to put southwest right here. Which angle up here is in the southwest? 5. So angle 1 and angle 5 are corresponding. Now I want to know angle 2. Angle 2 is up here. Where is angle 2? Angle 2 is in the northeast. Northeast right here. Which angle is in the northeast of this set? Angle 6. You could pause and finish all of these and see if you can figure them out. Okay, my next one, let's start with 3. 3 is down here. It is in the southeast. So 3 is southeast. Which one up here is in the southeast? Angle 4. Angle 3 and angle 4 are in the same corresponding position for the sets. Now, the next one here, we've done 4, 5, 6. Okay, we're going to go to 7. Angle 7 is in the northwest. So angle 7 is in the northwest, and angle 8. So those are my corresponding positions. They don't, right now, lines aren't parallel, they're just lines intersected by a transversal. They're not equal, they're not So nothing right now. All we know is where they are. So they're in the same corresponding position. Those are corresponding angles. Now, alternate exterior, the rest of these I like because they tell you in the name. Alternate exterior means alternate outside. So I need to separate these between inside and outside angles. I'm going to tell you that all of these in here between are considered interior angles. So the ones outside those lines are my exterior. So alternate exterior of the transversal. Again, you don't want 1 and 3 because those are right next to each other. We already know those are a linear pair. So I want alternate exterior of angle 1 and the alternate side of the transversal outside is going to be angle 2. The other outside is going to be angle 3. So angle 3 is outside. The other one that's the opposite outside is going to be angle 7. Again, not 7 and 2 because they're right next to each other. We already know that relationship. Alternate interior, angle 5. Alternate inside will be angle 6. Then we have angle 4. The alternate inside will be angle 8. So again, alternate and not in the same set. It has to be alternate in the other set, either the top or bottom. Consecutive or same side. I generally say same side interior, but the book says consecutive interior. They mean the same thing. So if I want same side interior, I'm going to say, okay, let's start with angle 4. What's on the same side of the transversal inside? It's going to be 6. And then we have 5. Same side inside is going to be angle 8. Okay, now the one that isn't mentioned here, and I'm not really sure why, is same side exterior. So I think we could use our inductive reasoning skills, looking at the patterns that are going on here, and figure out what our same side exterior is. And I believe that there's a question later on in the textbook that asks about that, but it's never mentioned for sure. But same side exterior would be angle 1 and angle 7, angle 2, and angle 3. So those are our angle relationships based on transversals. So we need to become familiar with these. You're going to learn more about them in the next class, the next set of notes. When lines become parallel, we know more. Okay, we should do review here. Go ahead and take a moment, plot these. I'm going to pause the screen for a minute. Graph these lines. Hopefully remember some of our original graphing of lines. In slope-intercept form, it's already in your y equals mx plus b format. Hopefully most of us remember the y equals mx plus b. Now, can we find the y-intercept? The y-intercept is your b. It is -1. Now, it's not just -1, it's the actual ordered pair. So technically, it's 0, -1. Now, your slope is what's in front of the x, it's your m, and it is -4/3. So you can plot this by plotting your y-intercept at 0, -1. Now you go up 4, and it's going to be a negative slope, so I want to go back 3, 1, 2, 3. And that creates a negative slope where it goes down left to right. If I had gone the other way, it would be going up. That would be a positive slope. Remember, we need to go down left to right to be a negative slope. So I could go down 4. If I go down 4, I'm going to go right 3, making that a negative line with an intercept of -1 and a slope of -4. Okay, the other review problem over here is when we use our y-intercepts. Y-intercepts are, excuse me, where we use that cover-up method. So remember, the x-intercept is when y is 0. So I'm going to go here and say, well, divide by 2, I get 5, and y is 0. Now the y-intercept is when x is 0, so you put in 0 for x, divide by 5, and we get a 2. So remember, the x-intercept is when your y is 0. The y-intercept is when your x is 0, and you get a number for the y. You get a number for the x over here. So I get 5, 0, and I get 0, 2. Plot those 2 points. And again, it's one line going through those 2 points. Right, arrows at the end, there we go. So it's not 2 separate lines. A lot of students like to draw 2 separate lines here, and they're 2 points creating the same line. I'm going to pause and go to the next screen. Okay, so again, this is factoring, and you should pause, work these out on your own. Try them, see if you can do them on your own. I'm going to work them all out with you one at a time right now, but you should pause and then come back and check. Okay, x squared right here, there's no coefficient in front of here, so I can just split up my factors. And I'm going to split up that x squared in the front and the back. X times x would be x squared. Now it ends right here with a negative. Anytime I have a negative right here, that means my signs are going to be different. So I'm going to have 1 plus and I'm going to have 1 minus. Okay, so I need factors of a times c. So a times c is 1 times 54, so I get factors of 54, or 1 times 54. I write all the factors. You don't have to if you see the combination right away. 2 times 27, 3 times 18, 6 times 9. Is there a combination of factors that is going to have a difference of my middle term? The combination is going to be 9 and 6. Which one has to be positive to give me a positive 3? So if I have a positive 9 and a negative 6, there we go, I'm done. Box that in. You can always check by foiling this back together, make sure you got the same answer. I also have students who have done this in the past, who will put like the 3 up here and the negative 54 down here. And this one up here, you add to get them, this down here you multiply, and then you figure out what numbers are going to give you that combination, and it would be positive 9 and negative 6. So I don't know if you've seen that before. You do not have to do this, but some people have done that in the past. Okay, so this one is similar, but it's a little bit different because of the 12, and again, we do it a little bit differently. So hopefully you're getting the hang of it now because I know we've seen it a few times. Just like I split up the x squared here, I'm going to split up 12x and 12x. Now again, that's obviously too much. 12 times 12 is 144. It's way too much. So because I'm multiplying an extra 12, I have to remember to divide the 12 out. So I've got to remember to put that 1/12 out here. Now, here it ends in a plus. If it ends in a plus, this means my signs are going to be the same. It doesn't mean they're going to be positive yet. I now have to look over here in the middle. They're going to be the same as whatever's in the middle. And the middle is a plus, so they're both going to be positive. Now again, just like I did over here with the AC, I'm going to do 12 times 5, a times c, 12 times 5, I get 60. Factors of 60, 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10. Okay, so I need factors of 60 that are going to have a sum of 16. Well, 1, 6, and 10. So I get 6 here and 10 here. Now we're not quite done because we have that extra 12 out in the front still. I usually do this in green, I'm not really sure why. So, is there anything I can divide on this side? Well, yeah, I can divide out a 6. Anything I can divide over here? They have a common factor of 2. And now 6 times 2. Is that my 12? So that's perfect. That is exactly what I needed to be to get rid of that 12. So I'm going to divide this side over here by 6, and I get 2x plus 1. Divide this side over here by 2, and I end up with 6x plus 5. Now again, you can always check this by foiling. 2 times 6 is 12x, 2 times 5 is 10, 1 times 6 is 6, 1 times 5 is 5. You add those two together in the middle, you get your 16. So again, I'm not writing this one out. I can, if anybody wants to come to office hours, I'll work any of those out if you want to. But there you go. Good luck with that. Cover them up. Practice again. See if you can do that on your own and remember those steps. Okay, this last thing we're going to do is going to be a proof. I'll try to do it fairly quick. I'm going to use yellow, blue, and orange for a highlighter. I'm going to highlight AB right here. It is right here and right here. I'm going to highlight BC right here, which is right here and right here. I'm going to highlight AC right here, which is the whole length, and it's right here. Also, 2 and 3 should be starred. Those are problems that you will definitely see somewhere else again, so make sure you study them. Okay, now things that I know definitely for sure. I should be able to fill some things in right away. Hopefully you can. Go ahead and do that. I'm going to pause. Okay, so here's where I'm starting with the proof. AB is in orange. ABC is here in blue. AC I have here in yellow. I'm going to fill in these pieces here because I know the given, so that goes first. And I also see that I have AB plus BC equals AC. I'm adding segments together here. Whenever you're adding segments to make a bigger segment, it's your segment addition postulate. And I'm just going to plug those in. What is it called when I can plug something into a proof? I can plug something into a proof, and it's called substitution property. The equality. Now, what I want to do is I want to look at this. So I took this and I substituted it in here. Now, I want to clear this fraction. I want to go from here and I want to clear the fraction. How am I going to get rid of the fraction? Hopefully everybody sees, well, there's only one fraction, so I just need to multiply everything by, I got rid of the fraction, I multiplied everything by 3. So, cancel there, give me 2x, 18, 9x, 30, 84. Now, clear the fraction isn't a reason. Like, you can't, what did I do to clear the fraction? I multiplied by 3. So this is my multiplicative property of equality. Okay, so now, what can I do? Combine like terms. And I'm telling you, I'm giving you some of these steps. Combine like terms over here, I get 11x. 18 minus 30, I get negative 12. Equals 54. Now we're just solving an equation. So combine like terms is a valid reason. Combine like terms on the side. I'm going to move the 12 over here. It's going to become 11x equals 66. I moved the 12 by adding it. So my addition property, you can use the symbol or write add equality. Now I'm going to divide both sides by 11. That will be my division problem. Okay, so that is it for our notes. Hopefully I kept it under 30 minutes. Sorry, I know they're long. I try to speed them up a little bit. Have a great day. Good luck with your assignments, and I'll see you in class or office hours.